Okay, so what we're going over today is actually the last thing in the chemistry unit. All right, so we're going to be done this unit by Friday, I'm hoping, so we can review on Monday, and then have your exam on Tuesday, okay, the 18th. Okay, reminder of a couple things coming up for you other than that unit exam on the 18th. Okay, your toxin project is due on the 17th, and your reactions assignment is due this Thursday. Okay. No, you had all day yesterday to work on it. Okay, so that's due the 13th. Okay, so make sure you've got that done. Alright, so what we're going over today is the mole equation. The mole equation is quite straightforward. Okay, it's not a hard thing to do mathematically. It's just a 3-variable formula. Okay, so we'll be going over that. Okay, what we have to understand about the mole is a unit. Okay, it's a unit that measures the number of particles of a substance. In other words, how much of something there is. Okay, in a similar way to how mass measures how much of something there is. All right, everybody follow me there? All right, so if I say I have 22 moles of sodium chloride, that means I have a certain amount of it. Okay, and we'll talk about how much of that there is. Okay, or how much of that is. Okay, in a little bit here. We need to understand the relationship between moles, mass, and molar mass. Okay, so like we said, moles is the number of particles of something. Mass would be the mass of that number of particles. Okay, molar mass is the mass of 1 mole. All right, molar mass is on your periodic table. If you look on your periodic table, these atomic masses, okay, that are on here, that is the mass of 1 mole of every one of these atoms. Okay, of every one of the elements, sorry, not atoms, every one of the elements on the periodic table, their atomic mass, that is their molar mass. Okay, everybody with me there? All right, so for hydrogen, okay, the molar mass, or the mass of 1 mole of hydrogen gas is sorry, not hydrogen gas, actually just hydrogen, is 1.01 grams per mole. All right, now, when we talk about the mole, we have to understand that the mole is an incredibly large number of particles. It's going to give us some sense of just how small an atom or a molecule really is. All right? To give you some idea, okay, we'll talk about this number in a minute. That is the number of particles of a substance that are in 1 mole. Okay? That's 602 with 21 zeros behind it. All right, so when I'm talking about 1 mole of hydrogen, I am talking about that many atoms of hydrogen. And that is a mass of 1 gram. That is the approximate mass of a raisin. Okay, so if you had 1 gram of hydrogen, you would have that many atoms of hydrogen. It's huge. Okay, it's a huge number because atoms are so incredibly small. All right. And then the last thing we're going to use here is the mole equation to solve problems. Okay, and what I'm going to do when we get to that is I will show you there's only 4 ways I can ask a mole equation problem. I will show you how to solve all 4 ways. Give you a solved example, record it on here, okay, so you can watch it as many times as you need to. You will know the only 4 ways there are for me to ask, okay, a mole equation question. Okay, so like we said, a mole expresses how much of something there is. Okay, so the amount of a substance in grams or the amount of a substance in moles. Okay, it could just as well be in liters, tons, molecules, doesn't really matter. Moles is just a convenient number. Okay, now we didn't just magically arrive at this number, okay, at this 6.02 times 10 to the 23. Nobody just went randomly said, I'm going to pick that number. Okay, it was actually arrived at based on using hydrogen. Okay, the person who originally came up with this idea of having a set number of particles, okay, was kind of thinking like a baker thinks. When you go to the bakery, what number do you usually buy things in? Dozens, right? Okay, you get eggs in dozens, you get donuts in dozens, right? Okay, we always get things in dozens. That's kind of the set number, okay, for certain types of things. Well, the mole is the set number for material, okay, for molecules and atoms and things like that. Everybody with me? So a mole works like a dozen. Okay, it's a set number. It applies to everything. If I have a dozen eggs, I have 12. If I have a dozen donuts, I have 12. Okay, if I have a mole of this, I have 6.02 times 10 to the 23 of it. Doesn't matter what it is, that's how much of it there is. Okay, so it's applied kind of in that fashion. All right, so we can't possibly count, okay, particles. So we use this representative number, okay, the mole. And because we're so busy, we abbreviate it, because we don't have time to write the E. So we abbreviate it MOL. I don't know why, but it's like, come on, we're so busy we have an abbreviation for at. Okay, we're that busy. Okay, so now we have an abbreviation for mole too. Okay, now the thing here about this 6.02, okay, times 10 to the 23, the way they arrived at this was, as the science of kind of particle physics was coming along, people were able to determine the mass of a proton, the mass of an electron, okay, and things like that. And they said, well, hydrogen is the simplest atom there is. It has one proton, it has one electron, it has no neutrons. So we're going to use it as the benchmark. Okay, we're going to figure out, because it's such a simple molecule, how many atoms there are in 1 gram. Okay, so obviously the 1 gram thing was just a little bit off. Okay, we can see that it's not exactly 1 gram, it's 1.00794, but it's close. Okay, really close to 1 gram. Okay, they figured out that if there's 1 gram of hydrogen and every proton weighs this much and every electron weighs this much, then 1 atom of hydrogen has this mass. So we divided 1 gram by the mass of 1 hydrogen atom, and we got this number. Okay, so that's how many there are. They applied that number then to everything. They figured out how much 6.02 times 10 to the 23 atoms of lithium would have a mass of, and how many, okay, beryllium would have a mass of. And what do we notice happens to the masses as we go along the table? They get bigger. Okay, and they get bigger because the atoms are getting bigger, right? In an atom of hydrogen, there's 7 protons, there's 7 electrons, okay? There's 7 neutrons. It's a bigger atom, so it weighs more. I shouldn't say weighs more. It has a greater mass, okay? You know, if we keep going down here all the way to something that's really heavy like uranium, okay? It has 92 protons, an ungodly number of neutrons, and 92 electrons, and obviously it's quite heavy, okay? So when we have 6.02 times 10 to the 23 atoms of uranium, it's obviously a lot heavier. All right, everybody with me there? Okay. All right, so we got to know this number. You don't have to memorize it, because it's going to be on every formula sheet and exam and whatever else that you get that applies to this. Okay, that's what we call Avogadro's number. Okay, so Avogadro's number is 6.02 times 10 to the 23, and it's the number of atoms, particles, molecules in 1 mole. Okay, and it applies to everything. Okay, questions on what the mole is? Old. Yeah, Avogadro was around a long time ago. Okay. Yeah, I just know he's the guy that came up with the mole. Okay. I'll show you a picture of him later, and you'll know why he named it the mole. This guy looks like a mole. He doesn't have a big mole, but he looks like a mole. Okay. Not the mole like the animal, the mole. Okay. The one that digs underground. This is an exponent, right? So this is saying it's in scientific notation. You guys have done that in math, right? Okay, so 6.02 times 10 to the 23 means 10 to the power of 23. So it means move this decimal 23 spaces this way, and you've got the actual number, right? Because our system of numbering makes every place a factor of 10 greater than the place before it. You guys follow me there? Okay, so this is 23 10 places back, all right? Oh, I don't know. Whoever came up with our system of numbering decided our system of numbering should be base 10 instead of base 4. I don't know why. It's just easier, I guess. Yeah? It's just the way we do it. Right? Okay. So the mass of 1 mole of a substance is known as that substance's molar mass. Okay? So that's an important thing to know. Okay? Molar mass is the mass of 1 mole of a substance. All right? Now, if it's an atom, or it's an element, that's pretty easy to figure out. We can just get it off the periodic table, right? But if it's a compound, we got to do a little bit more work, okay? It's not hard work, we just got to do a little bit more. So let's say I want to find out what the mass of 1 mole of water is. Okay, what's water made up of? hydrogen, and oxygen. Okay, so that's the formula for water. Well, every hydrogen has a molar mass of 1.01. And how many hydrogens do I have? 2. All right, so then I take hydrogen's molar mass, 1.01, and I multiply it by 2, because there's 2 hydrogens in this compound. What do I add to that? Oxygen's molar mass. Okay, and oxygen's molar mass is 16. Okay, grams per mole. All right, this is also in grams per mole. All right, so when I add those together, I get 18.02 grams per mole. Okay, so if I had 6.02 times 10 to the 23 molecules of water, it would have a mass of just over 18 grams. All right, does that sort of make sense? It's not a lot of water. Okay, 18 grams of water is 18 milliliters of water. It would be less than the tiny amount that's left in my glass here. Okay, milliliters are very small. Okay, so it's not very much. Think about it. A can of pop has 355 milliliters in it. All right, so 18 milliliters is not very much. Okay, atoms and molecules are, again, very, very small. Okay, everybody with me here on how this works? Okay, and here's what I want you to do. I want you to use your periodic table to figure out the molar masses of these compounds. All right, I want you to try them, and then we'll go through them together. All right, let's have a look at number 1 together here, just so we have another kind of solved example to work through. Okay, so I've got sodium chloride here. How many sodium atoms? No, how many sodium atoms? 1. How many chlorine atoms? 1. All right, so if I only have 1 sodium, I go 22.99 grams per mole, okay, because that's the molar mass of sodium, and I add that to the molar mass of chlorine, 35.45 grams per mole. Okay, and I add those two things together. Okay, 22.99 plus 35.45. Okay, and we get 58.44 grams per mole. Okay, our units are always for molar mass, grams per mole. All right, so these little numbers, the subscript numbers, are important. They essentially tell you how much to multiply the molar mass by when you're adding them all up. Okay, try the next one there. Okay, for the rest of the way through the unit, it'll be a good idea to have access to a calculator. You can use your phone for now, but on the unit exam, that will be verboten. Okay, that means forbidden. You're not allowed to use a phone on a test, on a unit exam, so make sure you have yourself a calculator. Just needs to be a simple calculator, okay, nothing fancy. You know, addition, subtraction, multiplication, and division. It doesn't even have to really be scientific at this point, okay? But if you're getting a calculator for use in science, get a scientific one, because when we get to physics, you'll want the square root button and all that kind of stuff, okay? So make sure you get yourself a calculator of some kind. All right, let's look at number 2 here. Okay, so I've got iron 3 bromide is my compound here. I have 1 atom of iron. Okay, so when I look up iron, it's 55.85. 55.85 grams per mole. Okay, and how many bromines do I have? 3. Okay, so I've got to go 3 times what bromine is, which is 79.90. Okay, grams per mole. All right, and that'll give me the mass of 1 mole of this stuff. Okay, so I've got 55.85 plus 3 times 79.9. All right, so 1 mole of this stuff has a mass of 295.55 grams. Okay. All right, keep going. Try the others. Okay, let's look at number 3 here. So we got diphosphorus pentaoxide here is our compound. Okay, phosphorus, there are 2 of them, so we go 2 times 30.97. Is that right? It's 30.97? Yeah. Plus 5 times 16. Okay, so 2 times 30.97 plus 5 times 16. Okay, so 141.94 grams per mole. Okay, so you don't have to write the units in on every single one. Just make sure you've got it on your answer. No, if I give you a compound like this, it's already done. But if I give you the name, then yes, you do have to swap and drop. Yeah. Okay, how many people are done number 4? How many people are stuck on number 4? Okay. So what we have to do when we're looking at number 4 is we have to interpret what all these little numbers mean. Okay? NH4 is ammonium. And it's in brackets, and there's a 2 outside the brackets. So that means there's 2 ammonium molecules. How many nitrogen atoms would there be in 2 ammonium molecules? 2. Okay? This is like N1H4. So there's 2 nitrogens, and there's how many hydrogens? 8. Okay? So that's what we have to do. We have to be able to interpret a chemical formula, okay, so that we get the right numbers here. Because if we don't get the right numbers, you're not going to get the right molar mass. All right, so we've got 2 times 14.01, that's our nitrogens, okay, plus 8.08, okay, that's our 8 hydrogens, 8 times 1.01, okay, plus sulfur, which is what, 32.07? Yeah, 32.07. And there's only 1 of that. Okay, and then there are 4 more oxygens, so that's 16 times 4. Okay, plug all that in. All right, so we got 28.02. That's our 2 nitrogens, okay, plus our 8 hydrogens, 8.08, plus our sulfur, 32.07, and then our 4 oxygens, 16 times 4 is 48. Okay, so 116.17 grams per mole. Okay, that's our molar mass for that one. Okay, number 5 is done in the same way. If you've got something in brackets, the number outside the brackets multiplies inside. Okay. All right, give you a couple minutes on the last one there. Okay, so let's look at the last one here. Okay, so we got scandium carbonate here. Okay, and we've got 2 scandiums, and it's what, 44 point something? 44.96. Okay, 44.96, and there are 2 of them, so we multiply it by 2. Okay, and then we add that to our carbonates. Now, how many carbons are there in 3 carbonates? 3, because there's only 1 in each carbonate, so then there's 3 of them. All right, so 3 times 12.01. Okay, and then how many oxygens do we have? 9. 3 times 3 is 9. Okay, so we got 16 times 9. All right, so when we put all that in, we got 44.96 times 2 plus 12.01 times 3. Okay, plus 16 times 9. All right, so 269.95 grams per mole. Okay, so is that fairly straightforward, figuring out how to do the molar masses? Really, you're just looking it up on your periodic table and adding them up. Okay, there's really not much more to it than that. All right, but it is an important step in being able to use the mole equation. Okay, because in the mole equation, one of the variables is molar mass. Okay, so you have to be able to calculate it so you can use it in the mole equation. All right, it's the one thing you'll always have. Okay, questions on that? All right. Okay, so when we look at a chemical equation, okay, and it's balanced, the numbers that we put in, okay, so these ones here, the coefficients that we use to balance the reaction, can mean a few things. Okay, they could literally mean you have 2 atoms of this, or 2 molecules of this, and 3 molecules of that. They could mean that. But if we were ever running a reaction on that small a scale, would we ever know what had happened? Not a chance, right? You can't see individual molecules. They're too small. If I was dealing with 2 molecules reacting with 3 molecules of something else, I'd never know what ever happened. Okay? So realistically, okay, what we're saying is I have 1 of this to every 3 of that. Okay, so there's 1 nitrogen for every 3 hydrogen molecules that are involved in this reaction. All right. Now that ratio could mean I have 1 mole of nitrogen, I have 3 moles of hydrogen gas, and that makes 2 moles of ammonia. That's usually what those balancing numbers mean. Okay, because usually that's the unit of measurement or the unit of use, okay, for a chemical reaction. It could also actually mean that the masses. If I had 1 mole of this, that would be 28.02 grams, and if I had 3 moles of this, it would be 6.06 grams, and so on. Okay, I would actually have to figure out what the masses are. Okay, so those coefficients we put in can mean a number of things. That's not really going to be important in Science 10. But it will be important in Chem 20 when you start using this mole equation to do something called stoichiometry. Okay? And in stoichiometry, you figure out how much product you're going to get based on the mass of whatever you put in. Okay? So if you had this much of something A and you had this much of substance B, you could figure out how much of substance C you would make and how much of substance B would be left over. Okay? And you'd be able to do that, but you don't have to do that in Science 10 anymore. You used to, but you don't anymore. All right? So essentially what we're saying is those coefficients could mean 1 molecule, 10 molecules, 1 mole, okay, 10 moles. It's just a ratio, okay? There's 1 to this to 3 of that, okay, whenever they react. All right, and so that's kind of what this is going through here. It could mean literally the number of particles, 1 particle of this to 3 particles of that, okay, whatever. This is Avogadro. He does look like a mole. Like he's got these big eyes and this gigantic forehead. Yes, but he didn't name his unit the bug. He's a strange looking fellow. Okay. How many people like Austin Powers? I think he's hilarious. Oh, come on. Oh, it's not going to play. Oh, I got to be on presentation mode here. There we go. Nope. Not going to play. Okay. Oh, sorry guys. I don't have them. They're not working. I did try clicking. But that's what I'm doing. My finger is the mouse. Seth's the lefty. Leave him alone. Yeah. He's amphibious. Okay. So the other thing it could mean is moles. Okay, we could be talking about the moles of something. 1 mole of this to 3 moles of that. Okay, we already talked about that part. Okay. Okay, the most important thing we got to remember here is that the coefficient makes sure that the equation is balanced, and it's going to make sure that we produce the right amount of everything on the other side. Okay, so now we got to talk about the mole equation itself. So this is the mole equation. N equals little m over big M. See, chemists have no creativity. There are 26 letters in the English alphabet, and they use the same letter twice in a 3-variable formula. Worse than that, the only other letter they used sounds like the other letter they used. N equals m over m. Ridiculous. Stupid. Okay? Anyway, here's what you have to know. The N stands for the number of moles. Okay? So N is the number of moles. All right? That's what the mole equation calculates, the number of moles of a material. Okay? M, little m that is the mass of the material, and that is always going to be in grams. Okay, the mass of the material is little m, and it's always going to be in grams. Okay, M, big M, capital M, is the molar mass. Okay, and that's that thing we just figured out how to calculate. Okay, and that is always in grams per mole. Okay, because molar mass is always in grams per mole, mass always has to be in grams. And what do you suppose the units for number of moles is? Moles, yeah. Actually, I should do that in green so it's less confusing. Okay, so this is in moles. Okay, or the abbreviation mole. Okay. All right. How many people can manipulate equations? That is, do algebra. Move a variable around to solve for it. Okay, good. Okay, quick little algebra review here because I know not everybody. Okay, second semester is always a little better because you've maybe had math already. All right. Let's say I wanted to solve for little m. What would I do? Right, I would multiply both sides by big M, okay, and that's my formula, okay? Of course you can. It's a smartboard. Look what else you can do with it. No, they don't, it doesn't bounce off of anything else, just off the sides. Okay, so if I want to solve for mass, okay, if I want to solve for mass, I multiply both sides by big M. So essentially, if you were doing this in math, you would do it like this. You go, all right, I multiply this side by big M, and I multiply this side by big M. Well, M over M cancels, and I'm left with this, okay? That's how you would do it if you were looking at it mathematically, okay? Okay, so we don't need those things. Everybody follow me there? Yeah? All right. Are you ever going to have to use this equation to solve for big M? No, you won't. Because where do you always get big M from? From the periodic table. You will never use this equation to solve for molar mass because you can always get molar mass off the periodic table. So that manipulation I just showed you is the only manipulation of this formula you will ever have to do. Okay, that makes using this formula pretty easy. You're either going to use it in the form it's given here, or you're going to go big M times little n equals little m. Okay, and that'll be the only manipulation you'll ever have to do. All right, everyone okay with that? Here's the thing I don't want to see. Okay, if I see this anywhere, okay, I do not want to see this. If I see you using a triangle, you can go right out the door and drop my class. Okay? Because the triangle is a crutch. It is a crutch for people who can't do simple algebra. I don't know who teaches you this crap, but I want to wring their neck. Okay? Okay? All right, then I'm going to go hunt McLeod down because I'm sick of people coming to me doing this. Here's why. Okay? Here's why I'm sick of this. When we get to physics, and I'm a physics guy, I challenge you to find a triangle that will solve this formula. Got a triangle for that one? Okay? No. It's got more than 3 variables. Okay? It just doesn't work. Okay? Triangles, the reason I don't want you to use a triangle is this. It'll last until the end of this unit, and then it won't. And if all you know how to do is draw triangles, it would be like you were walking around on crutches and I came along and kicked the crutches out from underneath you. Okay? Because that's what I'm going to do when you get to physics. If you're still using a triangle when you get to physics, you will be lying on the floor because I'm kicking out your crutches. Okay? You got to learn how to walk. Okay? You've got to learn how to manipulate equations on your own. Especially this one, since you only have to do one manipulation of it. Okay? Everybody got me? If you cannot do this simple manipulation, be honest with yourself. If this is really freaking you out, Science 10 is not the place for you. Okay? I'm going to be perfectly honest. All right? Because I'm going to give you way harder formulas than that you're going to have to manipulate. Okay? And it isn't going to work for a triangle. All right. So what I want to do now is look at some examples of how you might be asked to use the mole equation. Okay? I'm going to give you the 4 here. All right? You're definitely going to want to write these down because they're not in your notes. All right? So 4 examples. The only 4 ways you'll be asked about the mole equation. Okay, here's the first way. How many moles of calcium chloride are there in 90 grams? Okay, this is the easiest one. All right. Now, the first thing you should do whenever you encounter a problem that requires solving and has a little bit of math in it, and this will be important when we get to physics as well, the first thing you want to do is write down what the question gave you. All right? It's asking how many moles. Well, number of moles is n, and it didn't tell me that. That's the thing I have to calculate. All right? The next thing it told me is calcium chloride. If I know that formula, I can calculate this, molar mass. All right, so molar mass is going to be 40.08 plus 35.45 times 2. That should be 110.98. 98, yeah? Yeah, 110.98 grams per mole. Just double check if someone's got a calculator. I shouldn't do that in my head, but I'm pretty sure that's what it is. Okay? All right, now I've got my molar mass. What else did the question tell me? 90 grams. That's little m, mass. Okay, so I don't know what n is, but I know the other two parts of the mole equation formula. So n equals little m over big M. Do I have to manipulate this formula? Or is it already set up to solve for what I'm looking for? I'm looking for n. Is it set up already? Yeah, it's already set up to find n, so I don't have to do anything with it. I just have to plug in my numbers. Little m was 90 grams. Okay, big M was 110.98 grams per mole. Okay, so 90, yeah, when you got the line under, yeah, divided by 110.98. All right, so this is 0.81 moles. All right, so why did we write down our givens? Two reasons. First and most important reason for you, you're going to get a mark for it, so write them down. Okay, that's a pretty easy mark given that they were given to you. All right, second thing you would get a mark for, okay, using the equation properly. If you had to manipulate the equation, you would also get a mark for that. Okay, in this case you didn't have to, so that mark isn't here. All right, and then you'd get a mark for your final answer. All right, so that's a 3-mark question. No reason why we shouldn't be able to do well on a question like that. Okay, now what if you just wrote down 0.81 and you didn't put moles on the end? Would you get it right? No. Okay, an answer without units is meaningless and as a result wrong. Okay, so you need to make sure you've got units on it. If you solve for n, it's moles. If you solve for little m, it should be in grams. If you, okay, so make sure you've got the right units on your answer. Malcolm. Yeah, let's say two decimal places. Yeah. No, because the grams per mole is on the molar mass. Like, look at my math here, right? I divided grams by grams per mole. The grams cancel, and I'm left with moles, right? Yeah, round, let's say, to 2 decimal places, okay? Everybody with me there? Okay, so that's your first and easiest example. Everybody got it copied? Yes, that's what I did, yeah. All right. Second one you might get. What is the mass of 4.5 moles of magnesium bromide? And on a test, I would write it like this. I would give you the name, not the formula. Okay? Why does that make that question slightly more challenging? Right, you got to get the formula right. If you can't drop and swap this ionic compound, will you get the molar mass right? No. And as a result, you won't get the rest of the question right either. So it's really important to be able to do our formulas correctly. Okay, so our first step, as always, write down what we were given. Okay, first thing we were given, number of moles. N equals 4.5 mole. And then we were told it's magnesium bromide. Okay, first thing I would do, write the formula. Mg and bromine, this is a -1, this is a +2, so this is Mg Br2. Okay, so when we're calculating molar mass, we got 24.31, okay, plus 2 times 79.90. Okay, 184.11 grams per mole. Okay, and the question says, what is the mass? That means we're looking for little m. Okay, so there's your first mark. Okay, you've written down your givens. That's your first mark. Okay. Obviously, since moles are involved, we are using the mole equation. However, it is not set up to calculate m as it is written. So what do I have to do? Right. Okay. I want to take this m here and multiply both sides by it. All right. So I'm multiplying both sides by m. Okay. There we go. You would get a mark for manipulating the equation. That's a pretty easy mark too. Okay. Then you get another mark for essentially using your manipulated equation correctly. We call that the plugging stage. You're plugging the numbers in. All right. If you plug the numbers into the right places, you get a mark for that. Okay. So big M, 184.11 multiplied by little n, 4.5. Okay. That would be a mark. And then our final answer, okay, would be the product of those two things. So times 4.5. So 828.5, we'll say 5 grams, 828.5. Okay, so that would be a 4-mark question. Phil. So you're saying, can I plug in the numbers right from the start? Yes, you can. Just some people don't like to see, they like to know what they're moving, but if it makes sense to you to plug in the numbers right away, you do what makes sense to you. I'll be able to follow. Okay? Okay. That's what we did. Well, as long as you show me the manipulation. I showed the long way. I started out with that formula to show you all the steps. If you went straight to this step, that's fine. Okay. Okay, questions on that one? Okay, those are the two that are essentially kind of one-step mole equation questions. Okay, the next two I'm going to show you have an extra step in them. All right, it's not a hard step, it's just an extra step, and it involves using Avogadro's number. All right, now, Avogadro's number, that's 6.02 times 10 to the 23. What does that represent again? Not molar mass, but it's the number of... Okay, it's the number of particles in a mole. All right, so if I have 6.02 times 10 to the 23 molecules of water, I have how many moles? 1. Okay, 6.02 times 10 to the 23 is the number of particles of anything in 1 mole. Okay, in the same way that if I have 12 of anything, I have how many? Don't say 12. I have a dozen. Okay, if I have 6.02 times 10 to the 23, I have a mole. Okay, everybody with me there? Works just the same way. All right. Copy this one down. This is your third type of mole equation question that you might encounter. Yes. All right, so this question is different in that it's not asking me for moles, okay? It's asking me for molecules. The mole equation doesn't calculate molecules. It calculates moles or mass. All right? That doesn't mean it isn't entirely useless. Okay? It's still going to be used, but there's going to be a step after that. Okay? Here's what I have to remember. 1 mole equals 6.02 times 10 to the 23 atoms, okay, molecules, okay, particles essentially. Okay? Everybody with me there? All right. So if I find the number of moles of silver nitrate, would I be able to figure out how many molecules of silver nitrate I have? Yes, in this way. Okay? How many donuts are there in 2 dozen? How'd you do that? You did your times tables right. You went 2 times 12. Okay. So he went 2 times 12, and he said that in 2 dozen there are 24. All right. So if this is 1 mole, 2 moles would be how many times this number? 2. Right. Okay. So if I find the number of moles and multiply it by Avogadro's number, that'll tell me how many molecules there are, because this is the number in 1 mole. So if I have 4 moles, I have 4 times this number. Okay? If I have 5.678 moles, I have 5.678 times this number. Okay? You guys follow me there? Okay, so that's what we're going to be looking at next. All right, what does this question give me? First off, it gives me mass. 600 grams. All right? The other thing it gives me is that the material I'm dealing with is silver nitrate. All right, this is a -1 and this is a +1, so that's swapped and dropped already. All right, so if I want to find the molar mass of this, I've got 107.87. Okay, plus 1 nitrogen, 14.01. Okay, plus 3 oxygens. Oh, not 16. 16 times 3. Okay. All right. Everybody with me? Okay, so we'll figure out what that is. Okay, so 107.87. It's got to be on. 107.87 plus 14.01 plus 16 times 3. Okay, it's 169.88. You know what? I did one of these wrong back here, didn't I? When we were doing that molar mass thing, I did one of these wrong. Somewhere along the way I did. I said 16 times 4 was 48 when I did this one, didn't I? That number's not right. Okay, I screwed that one up. We'll go back to this though so we don't forget. Okay, so this is our correct number, 169.88 grams per mole. All right, so I have big M and I have little m. Can I find N? Yeah? Okay. So I use the mole equation here. N equals little m over big M, and I just plug in my numbers. 600 over 169.88. All right, so, whoops, not times, divided by. Oh, sorry, guys. 600 divided by 169.88. All right, so I have 3.53 moles of this stuff. All right, 3.53 mole. I want to find out how many molecules I have. In every mole, there's 6.02 times 10 to the 23. Okay, so what do I multiply 6.02 times 10 to the 23 by? That number, right? Okay, 3.53 times the number of molecules in 1 mole, okay, should tell me how many molecules I have when I have 3.53 moles. Okay, in the same way that when I asked Seth how many donuts there were in 2 dozen, he knew it was 24 because he went 12 times 2. Okay, 12 is the number in a dozen, and I told him he had 2 of those, so we multiplied them up. That's what you're doing here. All right, so our next step, okay, number of molecules, okay, equals n times Avogadro's number. All right, and that's going to mean then 3.53 for this one, moles, times 6.02 times 10 to the 23. Now, you're probably wondering, Mr. Coderre, how do I put that number into my calculator? Okay, well, if you weren't, you're brainy. If you were wondering, here's how. Okay, if you've got a scientific calculator, if you've got TI-83, okay, you're going to use what we call the EE button. Okay, your calculator, if it doesn't have this little EE here that's just above the comma, okay, it may have a button that actually has EE on it, or it may have a button that says EXP on it. All right, if it has that button, that's the button you're going to be using. All right, so here's what we do. We go 3.53 times, and then we use the brackets. Okay, you have to always enclose Avogadro's number in brackets. If you don't, it multiplies it using order of operations and not using the way you want it to do, because your calculator always defaults to order of operations. So it does parentheses, then exponents, then multiplication and division, etc., etc. Okay, so 6.02. Okay, and then I hit on the TI-83. I hit second, and I hit the comma, and it gives me this little e. The little e means times 10. Okay, then I put in to the 23. All right, like so. If you got an EXP button, you'd go 6.02 EXP 23. Everybody follow there? All right, so that's how you get that in there. Okay, close off the brackets and hit enter. There's how many molecules of silver nitrate there are in 600 grams. Okay, so in 600 grams of silver nitrate, there are 2.13 times 10 to the 24 molecules. Okay, and that would be my final answer, Devin. Yeah. Okay, questions on that one? Okay, anybody still need to write it down? Okay, last example here, or last type that you might run into. Okay, this last type, they give you the number of molecules and they ask you to find out the mass of it. Okay, so in this case they say you've got 1.54 times 10 to the 25 molecules of diphosphorus tetraiodide. Okay, and they want to know what's the mass of that. So this question in the end is looking for little m. Okay, it gives you the number of molecules. So you'd write that down as a given. And they also tell us it's diphosphorus tetraiodide. All right. It's a molecular compound, so I do not reduce those numbers. Okay, if it was an ionic compound, I obviously wouldn't leave it as 2 and 4. All right, but this is a molecular compound. The prefixes told me these are the numbers. All right, so if I'm going to calculate the molar mass of this, I'm going to have 30.97 times 2, okay, for my 2-phosphorus, and I can't remember what iodine is, 100 and something, it's big, 126.90 times 4, because there's 4 of it. All right, so my molar mass is 569.54. Okay. I can't use the mole equation right away, can I? I don't know little n. Okay, I don't know n. I don't know the number of moles. I don't know little m, I don't know mass. That's what the question asked me to find. All I know is molar mass. I cannot use the mole equation to start with. However, they told me how many molecules there are. Can I use that number to find out how many moles there are? Yes, because I know how many moles there are, or sorry, how many molecules there are in 1 mole. All right? So if I know how many molecules I have and I want to find out how many moles I have, what do? Divide, right? In the same way, if I asked Nick at the back there, how many dozen are there in 48? 4, right? He went 48 divided by 12. He found out there were 4 dozen. Well, now I'm going to do this. I'm going to divide what I've got by the number in 1 mole and figure out how many moles I have. Okay, so that's my first step. Okay, so to get n is going to equal then, okay, the number of molecules, okay, divided by Av's number. Okay, so in the case of this question, that's going to be 1.54 times 10 to the 25 over 6.02 times 10 to the 23. All right, anytime you've got numbers with those times 10s, you got to enclose them in brackets. Okay, 1.54 okay, times 10 to the 25. Okay, divided by Avogadro's number, 6.02 to the 23. All right, so there's 25.58 moles of this stuff. Okay, I know N and I know big M. Can I find little m now? Okay, now I can use the mole equation. N equals little m over big M. Okay, now I want to find little m, so I have to manipulate. So I'm going to multiply both sides by big M, okay, and that'll be my formula. So take my molar mass, okay, 569.54, multiply it by the number of moles I just calculated, okay, 25.58. And that'll give me the mass. Okay. Is that a lot? Yeah, that's 14.5 kilos of this stuff. Okay, so it's quite a bit. Okay. If you're looking at that in pounds, you'd be looking at close to 30 pounds. Okay, close to 30 pounds of this stuff. Yeah. Okay, so just let me get the answer in here. So 14,569.3 grams. Okay, is our final answer there. How far up do you need to go, Devin? All the way top. Yeah. All right. Okay, so we wrote down our givens. Okay, we calculated our molar mass. We calculated N using the number of molecules and Avogadro's number. Okay, and then from there we went back to the mole equation and calculated our final mass. All right. There's no tricks, guys. Those are the only 4 ways I can ask you a mole equation question. You have now seen how to do all 4. Okay? On the unit exam, I usually ask 3. Okay? And now you've seen how to do them all. All you have to be able to do is recognize the type of question and replicate what we did here. All right, now we are going to be working on this tomorrow and Thursday and probably Friday, okay, just so that we make sure we know how to do it. All right, and then we'll look at unit exam review on the Monday. Okay, questions on how this worked? All right. Okay, so quick review here. Let's say I want you to tell me how many particles there are in 1 mole of sodium. What's the answer? Right. Okay, because I asked, how many of that is there in 1 mole? Would it matter what I wrote there? If I wrote it was 1 mole of sodium, if I wrote it was 1 mole of silver, if I wrote it was 1 mole of water, okay, it wouldn't matter. Okay, 1 mole of everything is 6.02 times 10 to the 23. It's always the same answer. Okay, what if I, instead of asking for 1 mole, asked for 2 moles? What would you do? Multiply it by 2. Okay, I sometimes throw a question, like, honestly that easy on the unit exam, and people blow it. Because they look at that and they go, well, you never taught us how to do that. Okay, they totally look right past the question and don't see how easy it is. Okay, if something asks you how many particles are in this many moles, all you do is multiply by Avogadro's number. Okay, it's one of those steps that's kind of in other things. All right. Okay, so guys, real quick here, looking at the first one. Okay, so as we said, 1 mole of, it doesn't matter what I write here. If I have 1 mole of something, I have 6.02 times 10 to the 23 of it. Okay, but for B, okay, it says 2.5 moles of helium atoms. Well, it doesn't matter what it is. It's asking how much is there in 2.5 moles. So that means 2.5 times 6.02 times 10 to the 23. Okay, it's just like saying, how many are there in 2 dozen or 3 dozen? You multiply by 12. Okay, so this I think comes out to 1.505 times 10 to the 24 or something like that. Okay, everybody follow me there? Right? Do you do the same thing for the next two? If you want to find the number of molecules, you multiply by Avogadro's number. Number of moles by Avogadro's number, and you can't go wrong. Okay. No, it's got to go E23, because 6.02 to the power of 23 is not the same thing as 6.02 times 10 to the power of 23. Those are different numbers. That's why you got to use that E button. So you do it like this. Okay, so I would go 2.5 times, and then in brackets, 6.02 E23. Right? Boom, 1.505 times 10 to the 24. Yeah? Okay. No, well, the E is the 10. Yeah. Okay. You could put times 10 and then go power 23 if you wanted to, but lots of times when people do that, they end up putting in an extra 10, and we don't want that. Okay? This way always works right. Okay? All right.
Good afternoon, staff and students.